Okay, in this video, I will show you how to deal with arrival schedule. Basically, we want to have incoming entities from Monday to Friday, and there are not any entities coming into the system on weekends. Okay, I will show you two ways to achieve this goal. If you go to your source, okay, you can see in your property window, you can see the arrival mode. There are 4 options for your arrival mode, and by default, the inter-arrival time is chosen. Okay, this time we want to use the second one, is so-called time varying arrival rate. Okay, if you choose this one, you could say you need to give a read table. Okay, so first we need to create a read table. Let's go to the data portion, and you will say on your left, the third one is called read tables. Okay, we create a new read table. There are two things you need to define here, the interval size and the number of intervals. In our case, the arrival rate differs day by day, so the interval size we should use is 1 day. 1 day. And each week we have 7 days, so number of intervals we choose is 7. Okay. The model will automatically repeat this process from day 1 to day 7, and then go back to day 1 and go to the day 7. Okay. There is one drawback for using the read table, is that you could see the third column is called read. That means you cannot use your own probability distribution. You have to use the discrete Poisson distribution, and here you need to provide a mean value for the number of entities coming into the system per hour. So for TVA, we know it follows the exponential distribution with mean value 6 hours. So 6 hours is the average inter-arrival time. How many entities coming in per hour? In this case, it should be equal to 1/6, right? So it's around 0.167. So for the first 5 days, it should be equal to 0.167. 0.167. 0.167. And for the weekends, there are no entities coming into the system, so we need to choose 0. Okay, and we create another read table for model B. Similarly, we need to choose 1 day as our interval size. The number of intervals should be equal to 7. Okay, so the TVB follows the normal distribution with mean value 4 hours. Here we need to use 1/4, so it's 0.25. 0.25. 0.25. 0.25. 0.25. Okay. We could rename our read table. We could call model A read. Model B read. Okay, now let's go back to our source. So for the TVA, the read table, we need to choose model A read. Okay, and for the TVB, we need to choose time varying arrival rate, and the read table we choose model B read. Okay, now let's run our model. A little faster. here I write time days. It shows the time now, and we have the number of TVA and the number of TVB coming into the system. So from Monday to Friday, they arrive to the system normally. Okay, you could say after 5 days, the number of TVA and number of TVB will not change because nothing coming into the system. Okay. After 7 days, you could see new entities coming into the system. Okay. So in this case, from Monday to Friday, we have the TV coming into our system, and on weekends we don't have any TVs coming in. Okay. This is the first technique I want to show you, and you will see the drawback is we cannot choose our probability distribution. Okay. This way we choose a so-called arrival mode, and now I want to use the second technique to do the same thing. Okay, here we don't want to change the arrival mode, so we change it back to the interarrival time. This time I want to change the entities per arrival. From Monday to Friday, it could be still equal to 30, but for the weekends, we could change this number to 0. In this case, on Saturday and Sunday, there are no entities coming in the system. Okay, so here I have to use a global variable. So we go to the definitions, and we create 2 global variables. The first one we call the TVA batch, and another one called TVB batch. TVB batch. Okay, so for TVA, the entities per arrival, we use the TVA batch. And for the TVB, we use the TVB batch. Okay, the next portion is we have to find a way to assign the TVA batch and TVB batch based on the weekdays or the weekends. So we go to the definition portion, go to elements. We want to use timer this time. So I create 2 timers. So timer 1 I called open arrival, and the timer 2 I call close arrival. Okay. And the time interval I define here is 7 days. That means a week. Okay, 7 days. Okay. Here is equal to 7 days. Okay, and I want to assign a value of the TVA batch and TVB batch equal to 0 on Saturday. So the time offsite here I define as 5 days. That means this timer will begin on Saturday. Okay, and this open arrival occurs on Monday. Okay, so let's go to the process. I create 2 processes. The first one we use the open arrival event. This is our first timer. And second process, we want to use the close arrival. Close arrival. Okay. So for the open arrival event, we want to assign value for the TVA batch and TVB batch. Okay, so here we find that TVA batch it should be equal to 30. So this is the batch for TVA. Okay, so on Monday, the TVA will come into the system and the batch size is 30. Also, we want assign a value for TVB. So TVB batch equal to 20 on Monday. Okay. On Saturday, we will reassign the value for TVA batch and TVB batch. So we choose another assign. TVA batch equal to 0 on Saturday. And TVB batch also equal to 0. Okay. So now let's go back to our source. Okay, so now the entities per arrival for TVA, we use TVA batch. For TVB, we use the TVB batch. Now let's run our model. You could say from Monday to Friday, all entities arrive at the system normally. Okay, now it's 3 days. Okay, you could say on Saturday, there are no entities coming to the system. And Sunday, same thing. On Monday, next Monday, new entities coming into the system. Okay, so this is the second technique. Okay, so enjoy your homework.